All right, this first one up here, the molar mass of dinitrogen pentoxide. What is it that you need to do to get this? So what is it? 14.00. What is it? 67. And you're going to need to multiply that by 2. So that's the average molar mass for the nitrogen. And then you're going to add that to 15.9997 times 2. And you end up with, what is it, 32? Oh, sorry, not 2, 5. My bad. What does this equal? 108? 108.104, did you say? 0104 grams per mole. And then with sig figs, well, I guess there aren't really sig figs with this. It's all the numbers. So answer should look something like that. The units are grams per mole. So what do we mean by that? What does this 108 grams represent? Yeah, if I had 6.022 times 10 to the 23rd N2O5s, that substance, those number of substances, they would have a mass of 108 grams.
What's the unit that gives right now? It's mole and then like a subscript to the -1.
Oh, this grams times mole to the -1?
Yeah.
What does that mean?
That's just grams of moles actually.
Right. What is this? What does to the -1 mean? Divided. It means somebody didn't want to write that. So it was just an easier way to write it's in the denominator. I mean, they could have just wrote that, right? So what do these three things have in common? This, and this. They're exactly the same thing. There's nothing different about them. They're all exactly the same thing. Okay, explain how to count a substance by massing it out. So not all at once, just one at a time. So if you know the mass of one of the objects, and we could be talking about those tickets I was talking about with the arcade and Seaside, and then I know the mass of all of the objects, then I can just divide by the mass of the single object, and I can tell you how many of them that there are. No, you divide by the mass of one, not by one. So remember the pre-1982 pennies had a mass of about 3 grams? If I gave you a handful of pennies and you put them on a scale and the scale said that there were 150 grams of pennies there, how do you figure out how many pennies there are? 150 grams divided by 3, because that's the mass of an individual one. I can't hear you. I can't hear you. Yeah, so that 150 grams of the total mass of all the pennies that I'm looking at in this handful divided by the mass of one of the pennies individually. Okay, so I've got 5 moles of glucose. how many moles of carbon, hydrogen, and oxygen do I have? So I wasn't asking about grams. I want to know specifically about moles. So the answer to this is 30 mole of carbon, 30 mole of oxygen, and 60 mole of hydrogen. How did I get those numbers?
Just take 5 times.
5 times the subscript, right? So if you had 3 tricycles, how many wheels do you have? How many wheels do you have? You have 3 tricycles. 9. 3 times 3 gives us 9. Okay. So what if I had 2 dozen tricycles? How many dozen wheels do I have? Don't tell me how many wheels you have. Tell me how many dozen wheels I have. Let's back up 1 sec. I have 1 dozen tricycles, okay? So just tell me how many wheels we have. No, I have a dozen tricycles. I have 36 wheels, right? We're okay with that? There's a dozen tricycles sitting there. I'm looking at 12 of them, so I have 36 wheels. How many dozen wheels is that? 3 dozen. You meant 3 dozen. Okay, we'll go with that. So if I have 2 dozen tricycles, how many dozen wheels do I have? 6 dozen. I just take the dozen number, however many dozen I have, times however many of those objects are in that object. How many dozen handlebars do I have? There's 1 handlebar. There's only 1 handlebar. It is a bar, 1 bar.
Okay.
How many do you have? Then I have 3. If I have 3 dozen tricycles, I have 3 dozen handlebars. How many dozen pedals do I have? No?
Are you counting like the pedals together, like separate?
That's a crank. The thing that the pedals are attached to is a crank. 2 times, no, I don't have 2. I have 6. 2 times 3 dozen, right? Okay.
Can you use a different analogy?
How is it? How 3 is as low as I can go, really? I mean, what else do you want me to say? There's 3 dozen people in a room. How many shoes are probably there? In dozen. 6 dozen. Why? Because each person has probably 2 shoes on. I did see a really funny little GIF of this guy who was looking between the male logo and the female logo, and the male logo has pants on and 2 legs, and the female logo has a dress on, and it looks like just 1 large leg. And then he looks down, and he's missing a leg. So he's like, where do I supposed to go? All right, so the first thing I want you to do here is balance the chemical equation for the combustion of propane. So I said combustion, so what does that automatically mean that we're going to have there? So there's going to be some oxygen there. So I want you to look up the formula for propane, and it's C3H8 with oxygen. And I'm telling you flat out that you're going to create carbon dioxide and water. So there's your chemical reaction. So do you see how the stuff that we had last term, like if you don't remember how to write out what carbon dioxide is, it's going to be, or what oxygen is? Yeah. Okay, so now I need to balance this thing. I'm going to go ahead and put 3 in front of the CO2 to balance out my carbons. We okay with that? What do you want to balance next? So the hydrogens, I've got 8 on the left, I've got 2 on the right. If I put a 4 here, then my hydrogens are now balanced. On the right-hand side of the equation, I've got 10. We okay with that? 10 oxygens, 8 in the 6 in the CO2s, and then 4 more in the water molecules. And what about the oxygen on the left? What do I need to do? If I put a 5 there, then I've got 10 on each side. Great, so there's my balanced chemical equation. So I'm putting 25 grams of each of these in here. What kind of problem is this? It's a limiting reagent problem. I've thrown 2 things in. What's going to happen? What has to happen with this? The propane and the oxygen are going to react. They're going to combine to make CO2 and water. Then one of them's going to run out and the reaction's going to stop. So either my my propane or my oxygen, one of those 2 things is going to run out. 25 grams is going to get used up. I have to throw up 2 railroad tracks here just to determine who runs out first. So let's go ahead and do that. So I'll start out with 25 grams of C3H8. And then the next one is going to be 25 grams of O2. All right, so my mass is going to be 12.0111 times 3 plus 1.00795 times 8. Is that right? 8? Yeah. So this is a mass of 44.0966 grams for every 1 mole of C3H8. Where did that 44 number come from? Sorry, Destiny? Which numbers? The 44? That's why I just asked. Where did that number come from? I went to the periodic table and I found the mass of carbon and the mass of hydrogen. And I did what we did on the first question on this homework. So I said 12.011 is the mass of carbon on the periodic table. I have to multiply it by 3. And then I need to add that to the mass of 8 hydrogen atoms, which is 1.00795. And when I add all of that together, after I've done the multiplication, it ends up being 44. So what I'm saying is, if you had 44 grams of propane, you'd have what? You'd have 1 mole of propane. You'd have 6.022 times 10 to the 23rd propane molecules. So doing this first conversion, what have I now done? I have a mass of propane, and I do this conversion, and what do I get out of it? I get moles, but I'm counting them. This first one tells me exactly how many propane molecules I have. Do I have a whole mole of propane molecules? No, because it takes 44 to get a mole, and I've only got 25 grams. So I don't care that it's less, just that I know exactly how many that I have. So when I'm doing this, it's always going to be 1 mole of whatever it is divided by the mass from the periodic table. So now I know how many moles of propanes I want. Next thing I need to do is I'll put moles of propane in the denominator, C3H8. And I'm asking about water. So I'm going to go from moles of propane into moles of water. Where do I get the numbers for this? I look at my balanced chemical equation. So I'm going to put a 1 down here for the propane because there's a 1 up there in the balanced chemical equation. And in the water, I'm going to go ahead and put a 4 there for that because the balanced chemical equation shows me a 4. So now what I've done is I said I have this many grams, and this is how many propane molecules I have. And if I have this many propane molecules, I'm going to make this many water molecules. And now I want to know what the mass of those water molecules is. So then I'll throw the last piece in here, which is 1 mole of H2O and then grams of H2O. So 1.00795 times 2 plus 15.9994 equals 18.0153. So where'd this 18 number come from? Periodic table. And this 44 number come from? Periodic table. So you're always going to have to get 2 numbers off the periodic table. The mass of whatever I have and the mass of whatever I'm looking for. Yep. So then I've got this 18 times 4 times 25 divided by that 44 number, and I get 40 point, well, it doesn't really matter. I've only got 2 sig figs here because I said 25. So I've got 41 grams of water. So if I start out with 25 grams of propane and enough oxygen, I'll make 41 grams of water. Do I know I can make 41 grams of water? I don't know that yet. I might have run out of oxygen. So let's figure that out. So I'll do the next one here. And so my water, or my oxygen, 15.9994 times 2. So then this is going to be 31.9988 grams of O2 for every 1 mole of O2. So what's this first thing do for us right here? Counts. That counts how many molecules I'm starting with. Why do I care about the count? Sorry, Jake?
So I'm in the second railroad apart from 25 grams that you're starting to. It's always going to be the O2 and the mass of the O2. So it's going to be, you have 25 grams of O2, so then you're going to just set it to the 1 mole O2 and
every time, every single time. Because what I need to know is how many actual molecules I have. And the only way I can do that is to use this conversion factor right here, which is the number of grams per 1 mole. So I always set it to that. Why am I doing this? Why am I counting them? This chemical equation that we have up here says I need 1 of these, 5 of these, 3 of these, 4 of these. What does it not talk about? It doesn't care what the mass is. I need 1 and 5 to go together to make 3 and 4. So I don't care that I have 25 grams. I need to know how many actual oxygens I have, how many actual propanes I have. I count. I need a specific number of them. When you're building those tricycles, nobody said, I've got 27 pounds of tires here. Nobody cares about that. They want to know how many tires I have. And we started off with a mass. And what we need to know is how many of them that there are. Why do we always start off with a mass, though? Yeah, but why didn't I just go to how many there are? Why didn't I start with... Well, why don't I know? Because there's so many of them, I can't sit there and count them. I mean, it's a silly discussion when I say I've got 27 pounds of tricycle tires. Well, I would just walk over there and count the tires. Why aren't I just walking over and counting how many O2 molecules are in my 25 grams that I started with? Because I would be dead long before I could get in even a percent of them counted. So we're doing the counting by massing them out. So the second question on this is, how do you count by mass? This is how we do it. This is a mass. This right here is us counting. This is the mass if I had a mole of them, and this is how much I have. So I can figure out actually how many molecules I have, which is what I have to do every single time. Okay, so now I've got my oxygen, numbers of oxygens. So I will put moles of O2 down here, and I'm still looking for moles of water. So I'm going to do the exact same thing. I'm going to put a 4 here for that, and I'm going to put a 5 down for the oxygen because that's what my balanced chemical equation says. And then I'm going to keep going with this. So what did this next step do for me? So this is the mass I started with. This counted how many oxygen molecules I'm starting with. What is this step doing for me? It's counting how many water molecules I'm going to make. So I have a mass I'm starting with. I count how many of the molecules I start with. Now I'm saying how many of the molecules I'm going to make, and then I say what the mass of those molecules is going to be. And so then I'm going to go 1 mole H2O, 18.0153 grams H2O. So, what do we got here? 25 divided by my 31 number times 4 divided by 5 times my 18 number. I get 11.26 grams of H2O. Okay, so what do I know now? Say again? The moment that I've made this much water, what happens? I am out of oxygen. I know I started with the same mass of these, but that doesn't matter for two reasons. It doesn't matter. One, these things don't have the same mass. This one weighs 44, this one weighs 32. And every time I use one of these, what do I need to do? I need to use 5 oxygens. So I'm using up my oxygen molecules 5 times faster than my propane molecules. So I'm literally going to run out of my oxygens first. And I know that because what I'm saying is, if I started with 25 grams of oxygen and I had plenty of propane, I can only make 11.26 grams. Actually, I should just change that to 11, since it's only 2 sig figs. I can make 11 grams of oxygen. The moment I have made 11 grams of oxygen, what happens? Sorry, water. What happens? I run out of oxygen, and I'm sitting there with oxygen and CO2 that water and CO2 that I've just made, and what else is in the container? Leftover propane, because I don't use all 25 grams of the propane up until I make 41 grams of water. And I can't make 41 grams of water because I run out of oxygen too soon. I just randomly picked. A question that goes a little bit further for this would be, how much stuff is in the container when I'm finished? And tell me what that stuff is. So I would do exactly what I've done so far, and the first thing I need to do is figure out which one runs out first. And then, so now I know 2 things. I know that there's 0 grams of oxygen, there's 11 grams of water, and I'm going to need to do 1 more railroad track and then some addition and subtraction to figure out what's left in the container. So my next railroad track would be 25 grams of oxygen and then calculating out the amount of CO2 that would be made. And since I put 50 grams of stuff in, that means I have to have 50 grams of stuff when I'm finished. But I know I'm going to have a little bit of propane left over. So whatever this number is for the CO2, let's say it's 20. So then I've got 20 grams of CO2 and 11 grams of water. That's 31 grams of stuff, and the other 19 grams must be what? My leftover propane. So we'll do that one next time. One like that, or maybe one like that today. All right, this last one. So what is the point of this question? This is a limiting reagent problem, right? So in this case, what's the limiting reagent? The sweetened condensed milk. I've got a pint of this stuff, and if you look up the unit conversions for it, a pint is what? 2 cups. So how many pies can I make with sweetened condensed milk? I can make 4 pies. How many pies can I make with the eggs that I have? 18? Because 36 divided by 2 gives us 18. Can I make 18 pies? I've got plenty of eggs to make 18 pies. Why can't I make 18 pies? Because I run out of sweetened condensed milk. The moment I've made 4 pies, I can't keep going because I'm missing an ingredient. So that's really what the limiting reagent problems are. I keep making what I want until something runs out. So in this case, it's easy to see. It's just cans of sweetened condensed milk. But up here, it's oxygen. I have run out of oxygen, and this reaction is going to stop happening. Okay. So my answer for this last one is 4, because that.